today is actually just look at something very basic: volume ventilation. Nothing too powerful. Most people use it. And I've done a number of screenshots off the Bellavista because it's got some great graphics just to run through with you, because it would be the same information on any ventilator, right? And I've called it, what should we adjust and what should we monitor? Now, what's great about the new vents is that they can be configured. You know, older vents, what you saw is, you know, what you get. So I wanted to run through this and say, you know, for example, what are the correct settings with regards optimal eye time? And like I've always said, and I said this to Steve and many people, if the patient's sedated and paralyzed, then maybe it's a longer eye time is the better one to use. But do we consider adjusting the flow pattern? And what I want to do here is throw the challenges to you. Then you guys, I'm going to ask you what you think on each case. I'll show you the screen settings, what you would do. How much flow is required? I mean, do you just rely on the default of, say, is it peak flow or is it eye time, whatever you think, the flow pattern? Would you use a constant flow, square wave, a decelerating flow, or even a 50% decelerating flow? I mean, we do have options. I can recall a long time ago, we used to even have sine waves, but we've moved on from that. Okay, what should we monitor? What about lung mechanics? What sort of lung mechanics should we look at? What sort of pressures are important? For example, we know what peak pressure is and we know what plateau pressure is, but do we really use all the time, for example, mean airway pressure or driving pressure or something else, right? Also the timing of the breath, like IE ratios and so on. Do we look at those in depth? Work of breathing, some other things on power or pressure. And of course, what type of volume mode is the right mode? It's a bit of a quick, quizzy one. And I'm saying, do we use flow control or an adaptive volume mode, such as PRVC? So these are the things that what I consider looking at a very basic mode. So this is actually some screenshots I've taken off a Bellavista. It's quite nice. And you can see over here very clearly, it's volume assist control. Okay, these should all be the same, by the way. 400 ml tidal volumes, a bit of PEEP, 16 breaths per minute. Shows me the eye time of 1 to 2. So, a 1.2 second eye time, no plateau, dial out the flow trigger. It's a square constant flow. And what's good about this, all the new vents, is that we have an idea of time and also to the time between this and the next breath. So that's always the first part of the equation. What is an optimal inspiratory time? David or Matt, what do you think? My job is to ask the questions, present. Steve, this is reversed to you as well.
So well, you're asking for any, do you mean for any given patient? What's the ideal eye time?
I mean, that's right. What do we consider? Do we think about the eye time? I mean, actually, Matt, you triggered this off when you mentioned 0.8 of a second, and I'm going, So I thought I'd go back to this again and talk about timing.
So eye time in volume control, we don't really pay much attention to our eye time. We tend to think more in terms of, certainly the way we practice, we look more at what's happening with our eye to E ratio. And we'll adjust, we don't really adjust our eye time, but we adjust our flow in volume control to give us a reasonable eye to E ratio. And we try and keep our flow, I mean, if the patient's paralyzed, we're targeting a flow that gives us an eye to E ratio of around 1 to 2, or at least gives us E time that's long enough for the expiratory flow to get back to baseline.
Right.
And so we don't really target a particular number for the I time. It's more, I guess, what tidal volume we're giving to the patient and what I to E ratio we end up with. And our volume is usually based on their ideal body weight.
Yeah. David?
Yeah, I would say the same thing. I mean, this is almost a throwback because I have used volume assist control so little in the last 20 or 30 years since we've had modes like PRVC or now APVCMV on the Hamilton ventilators. So back in the day when we're using this, we would adjust. You didn't even have an adjustment for I time. It was inspiratory flow rate, and your I time and your IE ratio were dependent on what you set and the volume that was set as the tidal volume. But yeah, usually for most patients, we're looking for something like a 1 to 2 IE ratio, and whatever inspiratory time got that or whatever flow rate got you that was what you would target, I would say.
Yeah, and I would agree also, Graeme. I would look at this as a throwback mode. I would expect instead of I time usually to have a flow control there, and I would, being a decelerating flow nut, I would probably want to have my waveform in decelerating flow. And I agree with Matt that on the expiratory side, I would always want to see the baseline flow return to baseline, the expiratory side, and maybe hedge my bet with a little extra, knowing that there may be flow that's not communicated in certain patient types like COPD or what have you. Now, we learned earlier from Matt that seeing COPDers on ventilators is a bit of a throwback as well. But anyways, so that's my 2 cents.
So my bias is not volume ventilation, right? But over time, we're going to cover modes. And you'd be quite surprised around the world how many people still use volume AC. It's probably the most commonly used mode because people like numbers, right? And that's when you see it being used and you think about it, do they actually adjust the ventilator, or they just believe that the tidal volume is enough? And you know, you sort of see a lot of what I call desynchronous ventilation, because the ventilator is not being adjusted, it's just being set on a volume. Okay.
Yeah, Graeme, I would say the same thing's true in the US when we used to sell modes of ventilation, new modes of ventilation. At the end of it, when we went back in our post-market surveillance activity, when we looked at how physicians were using the ventilators, we found that assist control seemed to be more prevalent than we would have expected.
Yeah.
And yet we sold the ventilator based on some of the, quote, new modes of ventilation.
Yep. Well, you know, that's a good point, Steve, because the new modes of ventilation, for some reason, are not that popular. You know, people still use old modes, and I can see Matt smiling there. And we've all done these courses together before, and we still ask clinicians what do they use, and they use modes like volume AC or SIMV, modes that are 30 or 40 years old. And, you know, even going back to the publications from John Marini showing patients that creating huge negative inspiratory demand because the flow is not correct. You know, I mean, either the time is too long or the tidal volume is too small or whatever it may be, right? It's not being titrated. So screenshot was a constant flow, right? So what I've done now, I've just changed this now to a decelerating flow. You can sort of see over here, the flow decelerates. And what you can see over here on both of these, there's a peak flow. So this is the reverse way of looking at it. Your peak flow is there, your volume, your timing is here, right, over here. And the other side is a 50% decelerating flow. So if you it's, if you know ventilation, this is all pretty basic stuff. But I think for a lot of clinicians, when I go to ICUs around the world and see patients on vents, they don't make adjustments. So looking at these two over here, would you consider this to be better than this? Do we need to decelerate straight back to the full way or not? Do you think a complete deceleration is required, or this should be enough?
That's interesting. That's not something we would normally think about, actually.
That's right.
I don't even know on our ventilator if we can modify the deacceleration rate or how far it deaccelerates to. I'm not even sure. I've not seen that as a modifiable option. I just seem to be able to, all I can do is hit the waveform and choose, looks like square wave or deaccelerating.
Yeah.
So I guess it's not something, I'm not aware I could modify it. So it's not something I've thought about.
Yeah, that's okay. No issue at all. I mean, like Steve said.
So Graeme, is this something, so this is something that's only applicable in the volume assist control mode, right? What is it? Is this what you referred to as the 50% decelerating?
Yes.
Flow, the one on the right? I don't know if you can.
And what we might want to explain, Graeme, at least I'm going to have to refer to Puritan Bennett 50% deceleration methodology. But essentially, if you set a flow at 50, it would terminate at 25. And that's what it meant in terms of 50% deceleration. And what it also generally, I remember, at least in the 50% decels I saw, it would result in a shorter I time to achieve that same volume because, of course, you're sustaining a higher flow throughout the inspiratory time. So you would have theoretically a shorter I time to achieve that same volume. But maybe that's wrong. This appears to be a second each time.
Yeah.
And yet. Well, how does it guarantee the targeted tidal volume then if because based on the patient's physiology, getting down to that 50% flow, you may or may not achieve your tidal volume, right?
Yeah, of course. Because your tidal volume, your tidal volume is still a flow controller, right? It still controls flow to deliver volume. It just really, like Steve said, that you can say that halfway through the breath, the flow is decelerating to 50%, right? It's not
okay.
PRVC.
It's not stopping. It's just decelerating.
That's right. Yeah. But these are tweaks, right? These are tweaks of trying to. You think about it. So we've got I consider a short I time of 1 second. It's quite a short I time, right?
Depends on your respiratory rate.
Well, that's right. But again, if the I've done this playing with a test lung, so there's been no patient trigger or anything else. It's purely a controlled situation.
So Graeme, I see what's going on here now in terms of my comment. Generally speaking, I think I was right in that you would see a shorter I time if the peak flow remained the same. But I see the difference between those two waveforms is that the peak flow on the one on the left is 48 and therefore it decelerates all the way to 0. So you can come up with a mean flow, if you will, and that would effectively calculate your I time. Whereas on your one on the right, it appears as though you've changed the flow and it looks like 32 is the peak flow. And 50%, I'm guessing then 16 would be the terminal point when the flow hits 16.
Yeah.
Okay. Yeah. So I'm not familiar with this event, but that's what it appears to me. And I don't know. I like decelerating for a lot of reasons, but I don't know.
Well, Steve, all of us.
By the way, wasn't I'm trying to think back. Decelerating 50% was even available on the 7200
That's right.
perhaps. If I go way back, you know, then way back.
That's not going to reach. We don't want to that far back.
Yeah, and of course, you said earlier sine wave was as well. But anyway.
If you quote the MA1, Steve, we've all got problems.
I might quote the PR2 or the Mark 7, but
there you go. Or the good old Ambu bag.
Yeah.
Okay.
Sorry.
So here's a bit more of a to look at the screen blowing up. So just going to move over here the way. So we can see it the way the screen runs over here. It's volume assist control. It's a 400 mil tidal volume. It's PEEP of 416 through here. The I to E is 1 to 2. So what I've thrown in here is some of the issues of monitoring this, what we're going to monitor. And so when I play with ventilators, I like to look at what we can monitor. So we have some basic settings, some basic waveforms, right? Over here, I like the ability to make adjustments. So this can be configured to what I like to look at. So obviously, volume in, volume out, that's no big deal. Minute volume. I like to put in the patient's ideal body weight and gender, so we can calculate the ideal in mils per kilogram, because it's a lot of error when you ask people to guesstimate, are they do this correctly? You hear people say, oh, we put in height to get ideal body weight, but do you put in gender? Because you actually get a different formula. A lot of people don't. So that's important too. And then, of course, mean airway pressure and, of course, compliance or dynamic compliance. Any thoughts on this sort of measurements?
So this is monitoring on the right, or these are actually just...
No, this is settings.
These are derivative.
Basic setting, right? Basic setting. And this is some basic monitoring, pretty basic.
So some dependent variables, so to speak. But the VT per kg kind of, is that a monitored variable based on the tidal volume, or is that your setting?
No, in the setup, you put in the patient's height and gender, and it calculates their ideal body weight, and that would mean then as I adjust my tidal volume, would show me in mils per kilogram what we're delivering. I
guess where I'm struggling is I'm used to seeing, and this is just out of habit, like monitoring in one section, controls and pertinent parameters in another, and then waveforms somewhere else. And
so on the Bellavista, this is called the cockpit, right? This is purely like you're in the aircraft, right? You've got some information in front of you, right? Some basic settings. Okay, what am I looking at? I don't want to be flooded with too much information.
Okay.
So any thoughts? Is this good enough?
So
I like it. Yeah. I mean,
where's your pressures? I mean, you can look at them on the waveform, but I see.
Well, you got
there it is.
peak.
Right? It would have bit
you
me.
got peak and you got mean.
There you go. That's perfect. I missed it because it was so big.
That's the trouble, Steve. If people are vertically challenged, this could be a problem.
That's me. I have to look up. You know, I'm not used.
Don't worry. We won't hold that against you. So, Matt, any thoughts?
Yeah, how's the dynamic compliance? How is that determined? Is that just done from a inspiratory hold, and then it keeps that number until the next inspiratory hold?
No. It's actually, you can actually do this two ways. I wouldn't know the exact formula because I don't know the exact formula what is used, but it's actually used. I think there's always a point of like zero, a very, very small hold, because of the way it would work up here. This would be a calculation on this side over here. You can actually get the same thing too. If you put a static compliance, you can do a static compliance measurement, which then again is more of a true hold. But this is like a trending value the whole time. So it's being updated the whole time. Steve?
Yeah, the only issue with our old way of doing dynamic compliance is that, you know, it basically was pressure minus PEEP, and that was your delta P to use as your measurement against volume.
That's right.
And we would integrate some parts and other parts consider it noise. So each vent was a little bit different, but there was a difference obviously between that and the static compliance. I'm sorry, static compliance. And that was simply the airway resistance that we would see in the difference in the plateau if we were in volume. So this tended to have, I'm trying to remember, a little bit, this included and overestimated compliance a little bit versus static compliance. Is that correct?
Yeah.
Yep. So,
Okay.
Estimate or underestimate? I think it might underestimate.
It's yeah.
But not by much. I mean,
it's lower. But
so I have a question related to that. Do you guys think it's okay to do maybe plateau pressures? Just automatically, you know, apply plateau pressures to patients without, you know, being aware that you're, you know, that you're doing that, the ventilator to do that on its own just to provide you with that value. Is there anything wrong with that? And I know also more advanced techniques of compliance. When we were working on PAV and MAGD, we knew that we could oscillate sections of the airway in 200 millisecond intervals and look at the relationship between the oscillation and the pressure and the flow generation and actually make multiple measurements of dynamic compliance, which would give us different data. And then we would kind of do a least squares or approach to add that all up and give a reasonable dynamic compliance that was close to the static compliance. Is that kind of what's going on here, or is it more complicated, or is it a more simple approach? Or
well, in the Bellavista, what I'll show you later on, they actually have a lot of lung mechanics. It's quite a powerful package of lung mechanics. There's a lot of things. This is, as I said, Steve, I'm not 100% sure on the correct way the algorithm works. But I remember doing work with Giorgio Iotti, and he wrote the book I gave to you that time on automated lung mechanics and how you can do it. And it's the same, it's pretty much the same formula.
okay.
Yeah. Let me just continue. So we'll just go from here, and we've gone now from constant flow to decelerating flow, right? And pretty much you can just see from the graphics, pretty much the same stuff. I mean, the volume, minute volume, and so on. Okay, just continuing. And this one, of course, is the 50% decelerating flow. So you can sort of see an idea of the information a ventilator can give to you. Okay, so on the Bellavista, you can configure over here whatever you want to configure. So this is all, this can be built up to whatever you want to have, and I'll show you later on what you can measure. So it's a very powerful package, but this is quite, I would say, quite common on all new generation ventilators, that you want specific tailored information. The cockpit or the display should be able to show this of some sorts. Okay, so again, you can sort of see what I've played with over here is by saying I've just made little changes to see what I could do. Now I've made, that was there before, moved it up to there. Everything can be moved around. What's quite good on the Bellavista, you can actually freeze the screen. You've got some cursors to move across this and do screenshots. So again, nothing new. So here's an example like I gave over here. So if you're doing research or you want to look at true compliance or whatever, you want to run a workshop, you can have any patient on here, push the freeze button, and then look at whatever you want to look at to see, do we have auto peep or is the calculation right? And what's quite nice with the cursor, it gives you the absolute value all the way through. So you move it across there or through there, you get this information. So it's quite, you know, it's, if you're doing rounds, it's great for checking that your therapy is working. Okay. So what I've done over this one over here, I've had a play with the ventilator again, and I've picked up another measurement I've changed around over here. RCX, the expiratory time constant, which I like for a reason, because again, it's measurement of understanding resistance and compliance. And like you said before, when you're setting, like Matt, you mentioned a 1-to-2 ratio. But if we understand this measurement, it could be very helpful in how much E time do we have to play with, right? Because what we want to look at is really this part over here, right? So this is a measurement that has been taken from
Expiratory flow.
That's right. Yeah, I mean, this is to me an undervalued measurement, which I can use a lot.
Actually, that's quite a useful measurement, because one of the things I find is that there's been, sometimes you come along and there's been an obsession about maintaining a particular I to E ratio when the elastance is very high and the lungs are emptying out really fast. You actually don't really need to target that I to E ratio. And sometimes then if you can allow the breath to be a bit longer, sometimes you preserve the airway pressures a little bit for a given volume.
Yeah, and what's good, Matt, with this measurement is, for an example, if you have airflow obstruction, you get a longer value, or you have low compliance, a shorter value. So you actually have an idea of how quickly or slow the lung is emptying.
So you can assess the response to interventions, right?
That's exactly right. Yeah, and I'm not sure when people teach ventilation if they really understand this value.
We don't normally see that value on the ventilator.
Yeah.
And so basically what we don't see, we don't worry about, I guess.
And you don't know, right?
Yeah. Obviously everyone checks the expiratory flow waveform.
Yeah.
Make sure you're coming back close to zero before the next breath. But we don't actually have that number.
Well, the question then is, Matt, and I'm sure Steve will jump in here as well. Do you actually believe what you see here? Do you actually believe it's accurate? I can see Steve smiling like he knows the answer like me.
I know the answer has to be no.
Very good. Well, that's probably the correct answer.
That seems like that must be the answer, but yes, I do believe it. I put a lot of stock in what I see. Should I not?
No.
I guess the answer is no, but we practice as though it's yes.
Right.
I would say, my opinion is that it is, in terms of the ultimate value or the ultimate elements that you make your assessments on, it's just that I think what Graeme is referring to, and I could be wrong, is that there's a lot of, this is pretty. There's a lot of smoothing routines that occur in the application of user interface technology. And so what you see, what is of interest is if you get a flow measuring device and measure the precision of the devices that we're looking at, you'll find that there is a variance, that baselines, for instance, PEEP baselines do waver, that they're not as nice and perfectly on that baseline as you would think. The ability for the ventilator to achieve its peak usually is represented. I don't know of any ventilators that don't represent that, but it may not be as smooth of a transition. There's a lot of smoothing algorithms. I also know on expiratory side of things that for the spirometry elements, at some point we have to pick a point to stop integrating the flow over time to give you a volume. And that's the engineer's guess. Usually 5 liters per minute cutoff is pretty good, but you could potentially continue to have a leak lesser than 5 liters per minute that's not shown by certain ventilators.
That's right.
So, there was an article, and I've referenced this before on Ventilation Matters. I'll have to find it, and maybe we can talk about it. but out of 20 ventilators that were shown or that were studied during the pandemic, it was a significant amount of them, like 75% of them, didn't actually do what they said. And the reality, or the good news is, most of those ventilators are not ventilators any of us are going to use anyways. But and the good high quality ICU ventilators did tend to do that. But Graeme, I don't know if that's what you were referring to, or if that's the diatribe you wanted me to run off.
So the point I'm getting at, and I think we've all covered it in some sort of way, but for an example, like David, you use the Hamilton, and this is the IMT, or
Right.
the ventilator. What they both have in common is that they both use proximal airway measurements. They use proximal flow sensors, right? And so what you're measuring is actually what's happening down there minus the circuit, minus the humidifier. So what you see, but you also see a lot more noise because you're closer to the patient. You'll get, if you've got secretions, it's a different one where the vents that measure back either inspiratory and expiratory flow measurements, they do there's a lot of fudging can happen to smooth it off. And what I've done when I've been in the lab, I've actually put the proximal flow sensor onto the other machine to see what, and use it, with an oscilloscope to measure what's happening. And there's a lot of noise, but they don't show the noise. It's all filtered out. So when people say, oh, the waveform isn't so smooth, it's because it's filtering.
Or when it isn't smooth, it's because they're not, and they're showing you kind of the rawness of it. But I would still say that the major things that we use to guide and to make changes on the ventilator, most of the time it's related to trend. I mean, there are absolute values that are obviously important. Gas exchange is obviously important, but whether it's 16 and a half and then the next breath 17 and a quarter, those sorts of preciseness do vary in ventilators.
Of course. Yeah.
With the smoothing data, though, I would have thought with modern with computing and GUIs now, you'd be able to show both, wouldn't you? Like a smooth line over the noisy background trace. That would be interesting to see what that looks like, because then it would give us a sense of how much the smooth line is representing what's really happening.
Yeah. Believe which one you want to, right?
Yeah.
Yeah.
So, okay, the same one over here again, just using dynamic compliance again. And this one over here, I've changed around again. I've found out that in the Bellavista, I can actually have resistance as well. So that's, I like that. Things that we can actually show that the ventilator can be, made up to be what you want to measure. I suppose they can also do either inspiratory resistance or expiratory resistance. This
is calculated again?
Yeah. Over here, some issues of work of breathing, P0.1 or the PTP. I think that's important, but do we measure them much? Maybe with asynchronous ventilation, these things would be important.
Yeah, I think, go ahead, Matt.
I'm not familiar with, you have to define PTP, I'm afraid.
Pressure time product. It's really on. When patient's triggering this area down below here, how long it's taking to get back to the same point again, from like 5 of peak back to 5, for an example, where the P0.1 is really the steepness of demand. So it's like a neural coupling. Steve?
Yeah, I was going to say, Graeme, I think in general, when I have configurability and I'm ventilating a patient, the decision of how to set up my user interface is usually I would look at what mode obviously I'm in, and then what are going to be the dependent variables of importance, and I would want to see those. Then I would look at what the patient type is and also where the patient is in the stage of their disease. Obviously, I could care less about P100 if they're sedated, or I wouldn't be worried about PTP if they're not triggering. On COPD patients, I think, you know, I'm interested in kind of keeping an eye on their airway resistance and their compliance. I think on ARDS, I'd also probably want those two pieces in there. And again, it would just depend on the patient type, where they were in their course of their disease, and in terms of how I would configure what I wanted to see.
So this is what I wanted to show you. What I have on the Bellavista is what can be monitored. There's a lot more. There's a lot more I found. There's a lot more stuff there as well. But if you want to, you can go crazy and show stuff where you'll go brain dead if you really want to. But you can sort of see anything possible that can be measured is being measured. So again, on the new vents, this is what I think is great, because we have access to information that before we were guessing our way through. Okay, so basically, I want to use this as my last slide. Like I mentioned before, I'm going to run out of time, but just looking at really going back to volume ventilation. You can sort of see it's a lot more than just setting tidal volume or having flow. I think there's a lot of stuff, with lots of tweaks that we could do with it if we understand it. I do think eye time is important. If you're using it as an assist controlled breath as opposed to a paralyzed patient's controlled, like Steve said, it's a very different approach. But we can sort of see, though, over time, what's happened, haven't we? Everything still is lung protective, is still based around mils per kilogram. People talk about volume ventilation because you can control that. But you can work your way through here. What has happened in the last 20 odd years? It's been a lot happening from Keith Hickling's work with low tidal volumes and permissive hypercapnia. You know, plateau pressure, is that the right thing? High peak, low peak, driving pressure. I mean, it hasn't finished yet. People are still trying to work on more and more, you know, based on the good old ventilator, what we can be using, right? So that's my spin on a very basic mode. Any questions?
Graeme, could you uncouple it? Could you release the screen so that we'll get people talking in the final closing part?
Yep.
Here we go. Perfect. Thank you. All right, perfect. Go ahead, Matt.
Yeah, I think that final slide, Graeme, was missing one important thing that I think has probably become a bigger issue in the lower tidal volume era, and that's the concept of synchrony. And I think synchrony is hugely important, and what I'm finding overlooked, I think, because we get happy that we think we're on a protective tidal volume, but actually the patient is not comfortable with those settings, and they're working hard against the ventilator.
Fully agree. We will have a solution for you soon.
All you need to do is make the ventilator alarm so people stop.
Oh, that's a thought.
Yeah.
Saying synchrony not correct, or please adjust me. You make me happy. So if I can just jump in here to answer your point, Matt, that's very valid. Again, on a lot of events now, we have synchrony tools that can improve synchrony. I mean, in volume control, fixed volume control, you have issues with that. You have to make adjustments, right? But you can still do tweaks, but with more and more automation, like Steve alluded to. This is important. Just to move forward, we actually have another speaker coming up in a few weeks' time who's an expert in synchrony. So he should, he won't tell you who it is. You guys have to wait. Only Steve and I know. The top line guys only know what's happening. But you're right, Matt. It's a very important topic.
You must have meant someone else when you said.
I did actually. not you.
Yeah. Okay. Dave, any thought on you know, in your busy day, is this something, and Matt too, in your guys' busy days, which I know this is Ventilation Matters, and we like ventilators, but you've got more on your plate than just ventilation. I mean, it's certainly a key part of caring for your patient, but how much of this is of importance, and would you stop to pull up other parameters, or would you instruct the care staff to look at other parameters? I think that's a kind of an interesting
That's right.
thing, and would be interested in what Dave and Matt have to say before we leave.
Well, yes, I do pull up other parameters all the time, and again, using the Hamilton ventilators, there's a back screen, I guess you would call it, or you know, you touch to show the mechanics. Some of the things can be displayed on the front screen, but I don't think the number of parameters that Graeme just showed us can be shown on the front screen along with the waveforms. So usually it's a back screen that has all of those things that we just saw: the airway resistance, the compliances, auto PEEP, mean pressure PEEP, plateau, and peak inspiratory pressure. So I'm, you know, now every patient I deal with every day has ARDS because they all have COVID, and that's the disease. It's ARDS. So I'm looking at that on every patient every time I go in the room. I want to see what their plateaus are, their mean airway pressures, you know, what the ventilator is telling me their static compliance is, you know.
Yeah.
I mean, you know, I don't even have to do the math. I can just pull it up. So that's very helpful for me. I like what I saw on that. I guess that's the Bellavista, Graeme. And if I had that capability on my ventilators, I would probably put some of those parameters up there. For the ARDS patients, I would want to see the plateau pressure displayed, and if the ventilator could, either with an equation or with a short late expiratory hold, give me that. That would be great. And static compliance, mean airway pressure. These are some things that I might respond to as I see them trending in a direction I don't like.
I think with you know, following up, just to respond to Graeme's query, what more do we want? I think what we've found, and we've had a project running for a year or so now, is we have a project where we're just teaching our RTs and our juniors to identify and respond to the data that we currently have, and often feel that you know, we have quite a bit of data from our ventilator waveform screen, and it's not, unless people are taught to look at it and interpret it and react to it, it becomes useless information. And so we've had a project really actually focusing on synchrony and identifying asynchrony, and responding to it, and we've been able to demonstrate some improvement in patient outcomes and faster ventilator weaning, because we're responding and adjusting the ventilator to the asynchrony, not just putting the patient back to sleep.
I don't think that ventilators, part of the routine that mechanical ventilators have during the setup is that they're studying the resistance of the circuitry and the compliance of the circuitry. So they're really good at predicting or telling you what the actual patient behavior is at the Y without a proximal flow sensor. And I think that's actually been shown. Also in terms of speed and delay, you're talking about a millisecond a foot. And so with a 5-foot circuit, you're talking about the difference in data between a proximal flow sensor and a sensor that's inside the ventilator is 5 milliseconds in terms of recognition time. And Catherine Sassoon showed that in some of her work on flow triggering. So that's why many of the ventilators like Puritan Bennett and Event and Draeger and Siemens have went away from proximal flow sensors. That I think the way people practice is based on their training. And the reason there probably is a lot of assist control still in use is probably because people were trained to use it and they feel comfortable with that, and people use the tool they're comfortable with. I think marketing and ventilator manufacturers sometimes destroy that sense of willingness to be early adopters in the ventilator new modes of ventilation area, and that's because they label things that we know to be the same as others differently, and people just don't, I hate to say it, have time to sit and figure out what's the difference between a PIEND and a PEEP. So anyways.
Gentlemen, I have to go. I have another call to go to. It's been a great catch up. Thanks again for everybody.
Thank you, Graeme.
Yeah.
Thanks, Graeme.